In the previous video, we looked at the heat transfer equation and the thermal conductivity of different substances. Let's take a look at an example of calculating heat transfer. Find the heat flow in 30 days through a glass window of thickness 0.2 inches with an area of 15 square feet. The average outer temperature is 25 degrees Fahrenheit and the average temperature inside is 60 degrees Fahrenheit. First, let's write down what equation we will be using. Q is equal to K times A times T times delta T divided by L. There are a couple of tricks to watch out for in this problem. First, the window thickness is 0.2 inches. However, from a couple slides back, we know that the change in length or thickness has to be in feet, not inches. So you can take 0.2 and divide by 12 to see that this is 0.017 feet. Let's go ahead and start filling in the numbers we need. We can look up the thermal conductivity of glass, which is 0.5 BTU per feet degree Fahrenheit hour. The area of the window is 15 square feet. The time we are looking at is 30 days. However, time needs to be in hours, so we can convert this into hours by taking 30 days times 24 hours per day, and we end up with 720 hours. Next, delta T is the warmer temperature minus the colder one, or 60 degrees Fahrenheit, minus 25 degrees Fahrenheit, which is 35 degrees Fahrenheit. Last, we will need to divide all of this by 0.017 feet, which is the thickness of the window in feet. Going through the multiplication and division, we see that the heat transfer is roughly 11,117,646 BTU. Rounding to 3 significant digits gives us 11,100,000 BTU. In the next video, we will take a look at R value.